Hello everyone, today we're going to be looking at A-Maths chapter 5.1 Exponential Equations. So the objective of today's lesson is for us to learn how to simplify expressions involving exponential functions and also to solve simple equations involving exponential functions. We will require in this chapter to recall on the skills that we have covered in E-Maths, which is the indices, definitions and laws, and these are what we have covered previously. So, what is an exponential equation? It is one in which a variable occurs in the exponent. I have over here 2 to the power of x is equals to 2048, and this is an example of an exponential equation. We see that we have 2 as our base and also x in the exponent or index. Sometimes we also say that x is the power. So when we have a variable in the exponent or as the power, this is what we call an exponential equation. Let us now take a look at try 1. Without using a calculator, we would like to simplify each of the following. I hope that you find these questions familiar because they are no different from what we have done in E-Maths. Do take note that in this particular question, it says without the use of calculator. Hence, we will need to provide step-by-step working to show how we get the final answer. In this particular question, we observe that 16 is a common base throughout all the terms. Hence, we can apply these laws that we have here in order to get the answer to be 16. I will leave you to do the reading of each step to get the answer. Now let's take a look at part B. In part B, we notice that the bases are different, however, the powers are actually the same. Hence, what we can do is to apply these laws over here and then get the answer to be 2. I will leave you to do the reading. In this question also, we have an alternative method where we can actually change our 16 and 4 into base of 2. And by doing so, we can apply the laws that I have mentioned in part A to get our answer to be 2 as well. We need to be familiar with both methods. We cannot just stick to one of it. In part C, what we see is that we have the bases to be the third root of 3 as well as the fourth root of 3. We will change them to 3 to the power of 1/3 as well as 3 to the power of 1/4 respectively. Then, applying our indices laws, we will get our answer to be 3 to the power of 17/12. Now that we have already familiarized ourselves with our indices law, we will learn to solve exponential equations. In try 2, we want to solve each of the following equations. In part A, we have 3 to the power of 4x is equals to 81. What we will do is to change 81 to be 3 to the power of 4. Now that we have 3 to be the same base on both sides of the equation, we can equate the exponents. Hence, we will get the answer to be x equals to 1. Let us now take a look at part B. We have 9 times 3 to the power of negative x equals to 3 to the power of x minus 2. So similarly, our objective is to always have the common base, in this case 3, to be on both sides of the equal sign. In order to achieve that, we will have to change 9 into 3 to the power of 2. And then after that, we will apply our laws to get 3 to the power of 2 minus x. Now that we have achieved this equation, we will be able to equate the exponents, meaning to say equate 2 minus x equals to x minus 2, and then solve to get x equals to 2 as our final answer. Let us now move on to try 3, where we want to find the value of x for this particular equation. In this question, we will first move minus 64 to the power of 2 minus x over to the right hand side. Then, we will change 64 into a base of 4 such that we get 4 to the power of 3. We can also change both 4 and 64 into base 2. However, that is not necessary. Then, we will apply our indices law to get this equation. Subsequently, we will get the equation x minus 2 equals to 6 minus 3x by equating the exponents. finally, we will get the answer x equals to 2. I would like to also bring to your attention that this method that I'm going to show here is not correct. Let me explain to you why. In this alternative method over here, we see that 64 has been changed to 4 to the power of 3. And we know that that step is actually correct. Then, after that, we simplify it to get 4 to the power of 6 minus 3x, which is also correct. However, in the next step, we see that we have x minus 2 brackets, then minus away brackets 6 minus 3x. In this step itself, there is a problem. Do you know what is the problem? The problem here is that when we have the minus sign in the middle, this is a result of the minus sign from the previous step. However, if you're talking about powers over here, this minus sign in the previous step is not supposed to be brought over. Therefore, this is conceptually wrong. Hence, although our answer will be x equals to 2, which is the same as what we got over here, but due to the conceptual error, this answer that we have will not be provided any marks. We will now take a look at try 4, where we want to solve a pair of simultaneous equations. These simultaneous equations are not familiar to us because we cannot directly do substitution or elimination method. From the very first equation, what we will do first is to change 9 and 27 to a base of 3. Then we simplify the left-hand side in order to get 3 to the power of 2x minus 3y. We need to also be aware that 1 can be expressed as 3 to the power of 0. Then we have 2x minus 3y equals to 0. This equation over here is something that we are familiar with since Sec 2. Next, we will take the other second equation and also change the bases of 4 into bases of 2. Then, using our laws of indices and subsequently comparing our exponents, we will be able to get 2x minus 2y equals to 2. We can further simplify this equation by dividing by 2 across, and we get x minus y equals to 1. I can make x the subject, hence we will focus on x equals to 1 plus y as our second equation for simultaneous solving. Now that we have the two equations, we will substitute equation 2 into equation 1, and then we will be getting this. The rest of the steps are familiar to us, such that we will get the answer x equals to 3 as well as y is equals to 2. Moving on to try 5, we are given a particular expression and we want to express it into a certain form. In this form, we are also told that a and b are actually integers. I hope that you know what are integers. So let us first start off with part y. In part I, we see that we have bases 4, 8, and 2. Typically, in such questions, we will look for the smallest base. And then after that, think about whether the other bases, in this case 8 and 4, can be converted into that smaller base or not. In this case, the answer is yes. Then after that, what we need to do is to make use of our different indices laws and simplify our answer into 14 times 2 to the power of x minus 2. Observe that our final answer over here fits the form, where a is actually 14 and b is equals to 2. Although in this question, it did not require you to state clearly what is the value of a and b. So leaving your answer as this is sufficient. Looking at part 2, we are given the left-hand side of the equation to be the same expression as what we saw in part I. And then we have that equals to 7 times 2 to the power of y. So what we need to do is to make use of our answer in part I. which is 14 times 2 to the power x minus 2. With this equation, what we will first do is to divide by 7 on both sides. Hence, we got this equation. Then, we can make use of our indices law to multiply 2 with 2 to the power x minus 2. Hence, we get 2 to the power x minus 1. Then, to get the final step, we are actually equating the exponents. So, this is how we actually show that y is equals to x minus 1. In the previous examples, we have been looking at using equating of exponents to solve an exponential equation. However, that will not always work. So, in this example 6, we will be learning the substitution method. This question itself is not from your textbook, although there is another example, try 6, found on page 100 that uses the similar method. You may refer to it on your own. So in this question, we want to use the substitution u equals to 2 to the power of x to solve an equation looking like this. This is still an exponential equation because the exponents are having variable x. So in this question, we are also trying to find out what is the value of x. Not all questions will be giving you the substitution, so we need to be skilled to know what is the substitution that we will be using. Let us now start off with something simple. In this question itself, we will look at 2 to the power 2x plus 1 first. We first break it down into 2 to the power 2x times 2, and then for 2 to the power 2x, we can break it further into 2x to the power 2. In this form, using the substitution u equals to 2x, we will be replacing all the 2 to the power x with u. Then we will be getting a quadratic equation. The whole idea of using the substitution method is to eventually get a quadratic equation which we are skilled with in solving. To solve a quadratic equation, we will be using the factorization method. Otherwise, we can use the formula as well. I hope you are aware of what formula I am referring to. Then we will be able to get u is equals to half as well as u is equals to negative 4. I would like to caution you that this is not yet the final answer. Because as I mentioned earlier, the question is trying to ask us to find x. So we need to replace the u with 2 to the power of x such that we get these two equations here. Now that we have these two equations, we will proceed with solving it to get the value of x. So we need to see that half is actually 2 to the power of negative 1. Then we equate the exponents to get that x is equals to negative 1. So that is one of the answer. Now let's take a look at the second equation. Why is it that I have to reject it? If you were to substitute x with any value, positive, negative, fraction also possible, we will find that 2 to the power of x will actually always be positive. So because 2 to the power of x is always positive, it can never be equals to negative 4. Hence, this equation can never be solved. Therefore, we reject the answer. So in this question itself, we have the answer x equals to negative 1. I'd like to emphasize that although we are rejecting 2 to the power of x equals to negative 4, we still need to show this part of the working as well. We have now come to the end of today's lesson. You will have to spend the remaining time in this A-Maths period to actually complete the following classwork. If there is insufficient time for you to complete the questions, you may continue with it outside of the curriculum hours. Regarding the follow-up, for example, how to submit or how to check your answers, please refer to your respective teacher's preferences. Please take note there is also an extra question over here, which is not found in your textbook. Please copy it down. Thank you very much for attending to this lesson. I hope that you will have a great day ahead.